Welcome to my channel. I'm Zhang Xu. Let's look at the problem 29 in chapter 5. In this one, yes, I have to say it is a little bit difficult for the college student. It is still the slope problems, and then it tells you this person just move the angle theta, right? The angle theta, and then the bottom her speed is precisely half of what it would be if the slide had been frictionless. Calculate the coefficient for the kinetic friction. So in this one, we can see on the slope the initial velocity is 0, and in first situation this is frictionless. We can see the velocity is v, okay. And in second case, the velocity is half of the v because half of it by the velocity v2 with the friction. And then the total displacement is same because for the slope, this person just moved from the initial to the bottom, so the delta x must be same. Do you agree? And we need to find the mu k. It looks like when we solve this person on the slope, normally we can find the function with the acceleration with the mu k. Do you agree? So it looks like we need to find the mu k. Or find acceleration in first situation and acceleration in the second situation with friction. So this is two situations. This is the first situation, you can see, and then we can see we know the final velocity and initial velocity is 0. So the acceleration is 2 times a1, so we have 2a1 times displacement. The second situation, we consider the friction, so the final velocity is half of the v. So half of v squared minus the initial velocity 0 equals 2 times acceleration a2 times delta x, right? This one. And then in these two equations, it looks like we can find the relationship between a1 and a2. Do you agree? Yes. And this one, it looks like, can you do that by yourself? Yes. And you can. Now, I think you have the answer. The relationship between A1 and A2 is a ratio, right? 4 times. Now, we need to connect the acceleration with the coefficient. So we'll do the first analysis. First thing, we look at the case 1, frictionless. And then we find at the y component, we have the mn minus mg cosine theta. So the acceleration in this case is just mg sine theta. So at x component, mg sine theta equals mass times acceleration. So a1 is g sine theta. And then look at the second situation. We have the y component f1 minus mg cosine theta equals 0. And the x component, we have mg sine theta minus the friction equals mass times acceleration 2, a2, right? And then we can get the friction is mu k times f1. So this one, we know the acceleration for a2 is g sine theta minus mu k g cosine theta. See, we get the expressions in acceleration 1, acceleration 2 in function theta and mu k. So in the first equation we solved, we find the acceleration a1 equal to 4 times a2. Do you agree? Look at these two equations. We can say v squared is 2a delta x, so we can use that 1/4 times 2a1 delta x equals to 2a2 delta x. So delta x can cancel, 2 can cancel, so we get this a1 equals to 4 times a2. And then we input the expressions for a1 and a2. We get it looks like this one, agree? And then we can simplify this equation. We find mu k just 3/4 of tangent theta, and angle theta is given. So in this one, you can get mu k. See, is it difficult? Not so much, but yes, we need to find this use acceleration as a bridge to solve the mu k, right? So when you do these calculations, and then you find the mu k is 3/4 of tangent theta, and angle theta is given. You find the final answer is 0.51. Thank you.